Hey, so in this video, in this lesson, we want to see how to make the pad go back to the left once it got to the wall on the right. So when we play now in the game, the pad is actually going all the way to the right and stops. And we want it to change the direction, go to the left, okay? Because we've seen that if, for example, I change the direction here by putting -1, actually doesn't change yet. We probably need to change it for code again. But anyway, actually, it is a code issue, but once we change the direction, once we reach the right side, we want to change the direction, make it move to left. So before we go and solve this issue, let's think about it in another way before just going into the code and trying to write down the code that will make it work, which is usually what junior programmers try to do. So they would go to the code and start to figure it out. Why do I need to happen for it to move to the other way around? So to better understand it, I actually created here, this graph in the mirror. I use it a lot for all kinds of things, but also when I create lessons. So let's try to understand what happens. So we want to know when to change this pad from going from left to right to going from right to left. So this is the first situation. So here's somewhere in the middle. Okay, here we have the lim x actually. So let's put it like this. And this one is the lim x. Okay, so lim x is preventing us from moving once we get to it. So let me just color it a bit. Make it bold, and put it on some kind of it. Okay, so the thing is, if we have here the pad, and the pad, is moving here, and it got to the point where the x is equal or greater than the limit x, then it starts moving. It starts moving because it no longer creates the movement. That's important. It stops moving because it no longer creates the movement, because every time we enter the update, we've seen that the condition prevents it from moving to the right. When we check the condition, if we look at the code, when we check the condition, we see that position x is either greater or equal to limit x, so it wouldn't go into the scope and would move the pad. So if we want now to change it. Okay, so what we want to do is change the direction. So let's say we would do something like this. We would change the direction. So I'm taking this link, created a copy here. Okay, change the direction to the other way. And now we have speed equals 0.05, but the direction is -1. What's important to understand here is that even though we change it, it wouldn't move. Okay? So it wouldn't move because the x is still greater than the limit x. So it's a bit confusing. So let me show you how it works. Okay, we had this, right? And you can think of it as if the whole pad was on the underside because it was beyond the limit x. Okay, and now when we want to change the direction, we're still in the other side of the limit x. So we change the direction, but what will happen is we want it to note that it changed the direction and it can do the movement. So we actually want to make sure that we change the direction and change the movement at the same time. Okay, so how should we do that? Let's have a look. So we want to handle, this is the movement part. Okay, and movement will be the same whether we doing the first movement to the right or the second movement to the left after we passed the limit x. Now, in order for the movement to work, we just want to make sure the direction is in the right side. Okay, so we go inside the update and we have a certain direction. So let's say it's like this. So if the direction is bigger than 0, which basically means that the pad is going from left to right because the direction is larger than 0, then it adds the speed to the position x. So if the direction is 0, and, so this is the and sign for the if, and the pulse.x is larger than lim x, okay, larger or equal to lim x. In this situation, we want to change the dir. So dir, sorry, let me just fix it here. Okay, so it's like this. Greater or equal should be written like this. So we check two things: whether the direction is positive, which means that we're moving currently from the left to the right, and that the position x is still, and we check that if the position of x is over the right limit. So in this situation, we actually want to change the direction to be -1. Okay, so this is one situation we want to change the direction. The other situation, we'll look in a minute, but will be for the other way around. But once we change the direction and we go for the movement, it will start moving on to the other side. So let's have a look. This should work. So if I open now Unity, and run it, okay, then this was really nice, right? It hit the right limit and then started moving to the left, but then it didn't stop on the left limit. Okay, so let's make it move a bit slower and look again. So it's moving to the right and it passed through the left. So we actually need to do the same thing for the left side. So it will be very similar. We have this condition and we need to check the other condition. So we check the other condition by using else if. And else if is if we didn't do this condition, if this condition didn't turn out true and this scope didn't run, then it checks the else if. The else if is just another if that is only being checked if the first if hasn't been, confirmed as true. So the else if should be the other way around. So this one, the first one is for handle a change from going right to going left, and this one will be the other way around. So handle change from going left to going right. So going left is when the direction is -1, so when direction is smaller than 0. And the position, we want to change it only when it passed the left side, but we don't have it, right? We have a limit x for the right side, we don't have limit x for the left side. Okay, and if you remember when we worked on Unity, we calculated it, we moved it over here. But what we can actually use is that the camera is exactly in the middle. So what is the right limit is actually the same as the left limit, only with the change of sign. So the left limit will be actually minus limit x. Okay, let me show you why. If I take this one, okay, and we'll move it to the right, and we'll see it's about 2. Okay, now if I'll go and change it to -2, you'll see that actually touching the left side. So -2 will be the limit x for the left, the same way that 2 can be the limit x for the right. So let's use it. So I'll go back to the code. And here we check for dir was bigger than 0, direction was larger than 0, and that the position x was larger or equal to limit x. So we'll do the same for the other side. So position.x, this time we'll check if it is smaller than minus limit x. Okay, so if we had limit x 2, then minus limit x will be -2. And in this case, we'll do about the same thing. D equals 1f to go to the right. So this should make it move to the right, then move to the left, and back again. So let's have a look. We'll go back to Unity, and we run it. and goes from right to left, really nice. Okay, so you can see this movement working great. And just look, if I change the direction here to -1, it will start going to the right, to the left, and then to the right. Okay, and of course it will work in any position. I can take it up here, it will do it here. Okay, or down here, all the way here. It will just start from the right position and move. Now the interesting thing is, because we created the condition in the right way, it doesn't even matter if it's on the screen, if it pulls it all the way here to the left, okay, and to look, it's on the left, its direction is minus, so it will try and go and continue go to the left, but it will actually change the direction, go inside and stay inside. So let's have a look. Okay, really nice. Now, before we finish this, I want to show you another thing that's really interesting about game development, Unity, and actually writing code in general. And the thing about writing code is that you can always, once you have a logic that works, you can reuse it. What do I mean? So we have this sprite that's going left to right, and it has its own logic. And let's just create another one. Okay, I'll just go and create another 2D object, another sprite, and this time I'll take a circle. Okay, I'll put here, and I'll even change the color from the sprite render just to make it interesting. I'll put vent, and another thing, just put it outside. So this is currently just a sprite, right? It's a sprite render, it has a color, it has a shape, the circle, the graphics, it has the transform, its position, but doesn't have any logic. I mean, if I run it now, it does nothing. It just stays there. Okay, this one's moving, but this does nothing. But I can actually go to add component and select the same code of pad. Okay, and it will work. Have a look. I'll just press play. Didn't work. Why? Let me see. Okay, so we have the circle. Because it doesn't have a speed or limit, but I can actually give it a speed. Let's give it a speed of 0.07, which is quite fast. And there is, doesn't really matter, limit x, let's put the same as 2 and run it. So, okay, it moved inside. Okay, in a different speed. And both of them now inside. And both of them use the exact same code, only different variables. Okay, so what's important that we do need to update the variable and that we can have different variable values to each instance. Now let's not stop there. Okay, we can just code here. I'll place Ctrl D, this is for duplicate, and create another one, put it here, change the color to green. Okay, and another one. Okay, let's put it here and change the color to orange. And okay, all of these, because I made a copy from this one, okay, they have the same value. I can change it a bit. I can change the speed to be, let's make it 0.01. This is the first one. Okay, this one has 0.03, and this one should have 0.05. So all of them will get inside the area of the game, move from left to right, or right to left, and just stay there. Once they hit the wall, they just stay inside. And we can do that because we are using the same code and the code is working. Okay, so once we get the code that works, we can reuse it again and again. And that is one of the greatest advantages of working with code. So this is really nice, but let me ask you a question now. I just stopped this game, and you've seen we have if conditions. Okay, we have a lot of objects, and all that has different variables. And when we start the game, they start moving inside. But my question is like this. If I now run this game again, will this object move in a different way? And the answer is no. They will move in the exact same way. They will start with maybe with a bit different position and with different variable, but they will move in the exact same way because they are using the exact same logic, right? The whole code we write here, it changes the way this object works, but it does it in the same exact way. So if we want to change the way the program acts, we have to do one of two things. We have to either start looking for user input, which means the user using the keyboard, or another option is using random, using some kind of random number. Random number will work, but actually using a random is a bit like using user input. When we do random, we just take a random number that is based on the clock of the computer, on the clock of the mobile device we're working, which is another type of computer, but we actually just get some input which is different and use it. So random number or using input are the same, and basically the only way using different input is the only way to make our program act different every time. So we can add loops and we can add if condition, but the only real way to change the way that the program acts is either using input or using random, which is another type of input. So we'll see all this in our next video. Thank you very much for joining me. I'll see you next time.